Now, in this video, we will going to start with the projections of points. So first, the moment when we talk about the projections of points, we will going to have the quadrant system. So we have from 0 degree, if this is the line of 0 degree and this is the line of 90 degree, then it is from 0 to 90 is called the first quadrant. So now we will going to take up the projections of point in the first quadrant. So the point, when the point is in space, that is capital P, it is always denoted by capital letter point P. So when the moment when we talk about the point capital P, that means the point is in space. So what will be the condition of the point with respect to the vertical plane, the horizontal plane and the profile plane? So that is the one which we need to understand. So since it is a orthographic projection, since it is a projections of points in the first quadrant, so always the point is with respect to some distance with respect to vertical plane and some distance with respect to the horizontal plane and some distance with respect to the profile plane. So obviously we have three different planes. If I want to see the image on three planes, that means suppose if I want to see the image in the vertical plane, then I should look in the direction perpendicular to that plane. So that means I have to see the object from the front view, because the front view is perpendicular to the vertical plane. What happens to the position of the top view with respect to the vertical plane? The top view will be aligned with the vertical plane, so obviously you will not be able to see the image in the top view on the vertical plane. Similarly, when you look from the left side view also, and the left side view is aligned with the vertical plane, so obviously you will not be able to see the image on the vertical. Whatever the image it is there in the vertical plane, we will not be able to see when you look from the left side view. So obviously only when you look from the front view, since front view is perpendicular to the vertical plane, so I can see the point on the vertical plane. Since the image is on the vertical plane, obviously it will be P dash. Always the front view is denoted by P dash. Now, similarly, when you look from the top view, what happens? I can see the image on the horizontal plane because the top view is perpendicular to the horizontal plane. And similarly, when you look from the left side view for the, suppose if you want to see the image of the on the horizontal plane, if you look from the left side view, again it is not possible because left side view is aligned with the horizontal plane. And similarly, the front view is also aligned with the horizontal plane. So only in a direction perpendicular to the plane can be able to visualize. Similarly, if you see from the right profile plane, if you want to see the image on the right profile plane, then I have to look in the direction perpendicular to that plane. In this case, we have considered the left side view. So left side view is perpendicular to the right profile plane, and whereas top view and front view will be aligned with the right profile plane. Therefore, to image the scene, the right profile plane, I have to look from the left side view. So now these are the things which is the basics which we are looking at. So that means since I will be able to see the images in the vertical plane, horizontal plane and the profile plane. But now what is the condition is the condition of the point which is capital P is in space. Now what is the position of the capital P with respect to vertical plane, with respect to horizontal plane and with respect to the profile plane? Now we are going to look into that. So when we look from the front view, I can see the distance of the point above the from the horizontal plane. I can see the distance from the horizontal plane. So what is the condition? When you look from the front view, I can see the distance of the point capital P is above the horizontal plane. So since the image will always be seen in the vertical plane, therefore I can see the distance above HP on vertical plane. You can see here the above HP is on vertical plane. Similarly, when you look from the top view, I can see the distance of the point capital P is from the vertical plane. So that is this distance what we are looking at. So when you look from the top view, I can see the distance in front of vertical plane. So that in front of vertical plane, that image will going to fall on the top view, which is small letter p, and this image is in front of VP. Similarly, now when we are considering the point which is with respect to the profile plane, if you consider with respect to the profile plane, when you look from the front view, I can see the distance in front of, I can see the distance from the RPP. But now, if I want to see the image on the right profile plane, I have to see in the direction perpendicular to that plane. So the direction, as I already told you, which can be from the left side view, but also I can see the image when you are looking from the right profile, that is right side view. Why? Because both the directions are perpendicular to the right profile plane, and also that all the planes are transparent. So from which direction I should look? So that is the reason why we are given that the condition with respect to VP is in front. So the point is above HP, in front of VP, and in front or behind or from RPP. So that is the condition. But out of which we have to consider only any one of these conditions will going to satisfy the right profile plane. So which is that? So we will going to see that now. When you look from the left side view, the point is between the right profile plane and the view. That means the object is between the plane and the observer. When you look from the right side view, the plane is between the object and the observer. Observer is looking from the right side view. Similarly, when you look from the front view, I can see the object is between the plane and the observer. Similarly, when you look from the top view, the object is between the plane and the observer. So, the left side view also the object is between the plane and the observer, but only the right side view where the plane is between the object and the observer. Always the condition of the front view has to be satisfied when you are looking from the profile view. So what is the condition of the front view with condition with respect to the observer in the case of the front view? The object is between the plane and the observer. Since the object, same condition has to be satisfied when you are looking from the profile view. But in the profile view, we can see the right side view is not satisfying that condition because the plane is between the object and the observer. Therefore, when you look from the left side view, you can see the object is between the plane and the observer. So this condition satisfies the conditions of the front view. Therefore, I have to see always in the first quadrant for the right profile plane, I have to look always from the left side view. So when you look from the left side view, the object is in front of RPP. So that is the reason why you are getting the object is in front of RPP. So when you look from the front view, I can see the image in front of RPP and that falls on the vertical plane. And also when you look from the top view, I can see the distance in front of RPP. That image falls on the profile top view also. So then when you look from the left side view, I can also see the distance above HP. That image go to falls on the vertical plane. And when you look from the left side view, I can also see the distance in front of VP. That image will go into falls on the profile view. Therefore, the final condition what happens is the point is above HP. So that is above HP, in front of VP, in front of VP, and in front of right profile plane. Now, in the next condition, now we will going to see individually how it will going to happen. So when the point is above HP and in front of RPP is the front view. So that means when you look from the front view, I can see the distance above HP and also I can see the distance in front of RPP. That when you look from the front view, since front view is perpendicular to vertical plane, so that image will going to fall on the vertical plane, and since it is the front view, it is always gives with a dash. So that means it is above HP and in front of VP will come on the vertical plane. So always, in other words, the distance with respect to HP is always seen in vertical plane. So that is the condition. The distance with respect to HP and RPP is always seen in the vertical plane. So image is the front view. Now similarly, when you take up the top view, when you look from the front, top view, I can see the distance in front of VP and also in front of RPP. So that image will always falls on the horizontal plane. Since the image is on the horizontal plane, so it will going to become small letter P. So that is the image of the top. Similarly, when you look from the side view, I can see the distance above HP and also in front of VP. So that image will going to fall on the right profile plane in front of VP here and the above HP here. So the distance with respect to vertical plane and the horizontal plane is always seen in RPP. So the image is the side view. Since you are looking from the left side view, so P double dash will be always, it is left side view. Then, and this is the how it will going to be able to see in 3 dimension. Now when it is rotated, so obviously what we do here is we will going to cut the vertical plane here. So we will going to cut the horizontal plane here and then rotate the HP down and RPP to the right side, so that vertical plane is always fixed. What happens? The correspondingly, the image will also be get rotated. So this is the intermediate positions of above HP and in front of VP. See how the horizontal plane is going down and right profile plane going towards the right side. So correspondingly, the image after the rotation of 90 degree, so since it is rotated by an angle of 90 degree, therefore the final orthographic view will going to be like this. And here, when you want to draw, so when you want to draw this, first we will going to draw the XY line and the X1, Y1 line, and then identify the planes. Identify the planes means the vertical plane will be here and the horizontal plane will be bound down and RPP will going to come to the right side. So then the distance with respect to the profile plane that is in front of RPP is seen in both VP and HP. So you take the distance in front of VP, RPP in both VP and as well as in HP. So you will going to get a line parallel to this X1, Y1 line. Then the distance above HP is seen in the vertical plane. So above HP distance is in vertical plane, and the distance with respect to HP, with respect to VP is seen in the horizontal plane. So HP is down, so HP it will going to be rotated, and you will going to get the image here. So then, and what happens is the distance. Now when you come to the here in the profile view, so when you come to the profile view, you can see, when you look from the side view, we can see that P is here, P double dash is here. Above HP is vertical here, and then in front of VP has become horizontal here. But in the top view, in front of VP is vertical. So when it is rotated to the by 90 degree with respect to the profile view, then this vertical line has to become horizontal. So since the vertical line has to become the horizontal in the profile view, therefore what happens, and both P dash and P double dash both will going to lie on the same line. So to do that, so that is the reason why here we are rotating by an angle of 90 degree, 45 degree, so that here when you draw a line at 45 degree, then what happens, the distance in front of VP in the top view is vertical, is transferred into horizontal distance in front of VP. So P double dash will going to be, so you project the top view point onto 45 degree line, the distance with respect to in front of VP is in vertical position, is transferred to the horizontal distance. Then where you have the front view, on that line you will going to get the side view. So draw a horizontal projector from P dash and draw a vertical projector from this 45 degree line. Both will going to intersect at this point. So you will going to get this point as P double dash. So this is the final orthographic view of the generalized projections of points in the first quadrant. Thank you.